live now. Got a small file printing right now. These damn fidget spinners, man, sell like crazy. I mean, I don't know. I can't print them fast enough. But they're fun. So, on to today. Today we're going to go over this, to me, absolute ridiculous nonsense of safety issues with 3D printers. Um, yeah. So if anybody hasn't seen it on Reddit yet, an ANET A8 user had a legitimate printer fire. He ended up burning it down to the ground. So, as the fire department was involved, I'm sure, it's getting highlighted on Reddit right now. It's pretty serious. Um, this isn't just a smoke issue. Uh, if you ask me, smoke and fire, they're the same thing. Alright, yes, okay, smoke's not as serious. Smoke can become a fire, whatever. I'm not going to get into the pissing contest of defining a smoke or a fire. Totally separate issue. Either way, it's bad news. Um, but now let's go over this. We don't have the exact cause, what specific part caused the fire. Um, I don't have those details. I didn't see it in the discussion. He doesn't know because he left his printer unattended. So I'm just saying he. It might be a she. I don't know. It could be a she due to the 2.5% of you that are female in the group. Um, so what ended up happening was that it completely burnt out. But the causes are a couple. Um, we all know at this point about toasty terminals. Um, you know what? I have a spare board. Let me grab it. One of these boxes. When we say toasty terminals, we mean. Let's see if I can find the bed one. Oh, there we go. One of these went go. Right there. That is a heat bed terminal. Um, this is a generic. Does it even have a brand name? No, it doesn't. It's just a generic board that came with my printer. If you have this printer, it has this one inside of it. But what happens is the plastic here actually melts. So why does that happen? Well, everybody gets to watch that fucking dance. Have fun. Why does that? Why does this plastic melt after going through the wire and all the way through this PCB here? Um, why does it melt right there? Well, that's a connection. So anytime you have a connection, you have a chance of introducing resistance into the system. And when you introduce resistance into a system, resistance equals heat. Okay? Heat bed, resistance wire. Like electronic cigarette, resistance wire. Okay? You flow electricity through it, the resistance develops a restriction to the flow of amperage and develops heat. Now, a higher voltage can overcome more resistance, but it'll still slow down the amperage and thus generate heat. So we keep on coming back to this. Amperage is the heat. Let's go into the garden hose analogy because it just works so well. We're going to look at three parts here, right? You have a garden hose on a spigot screwed in. If you try to put your hand at the end of a garden hose with it wide open, you're going to feel a force. That force is the voltage in the electrical analogy. If you just have it going, the volume of water that's coming out of the hose is the amperage, okay? And the resistance will be like if you screw that nozzle shut a little bit. So those are your three parts. Now, let's look at it. Because the garden hose itself is a certain, or actually we'll look at the spigot. Because the spigot is a certain size, wide open will offer a little very little resistance. There'll still be some, but not a lot. But if you start closing it down, that's going to lower the resistance. Now, this is where it all comes together and they all start connecting together. Because you created that resistance, less water can flow through it. So that means less amperage. Now, if you had your city water or a well water, you have a specific amount of force being pumped through there. So there's water pressure in your house. Coming straight from the tap on the street can be up to 90 psi. So that we'd consider that a higher voltage. Coming out of your average pump could be lower, especially if your pump's getting old. So you'll have less water pressure. So it's not going to overcome as well. But if you take that spigot on the wall and close it halfway, you're just going to get a little bit of water coming out. And the pressure is not going to be as good anymore because that pressure is being dwindled down by the resistance inside of the spigot. So let's look back at this, okay? Where you make your connections here can develop resistance. How electricity flows is not really through the inside of a conductor, but on the outside of a conductor. So surface area is what flows electricity. Now let's take a look at this again. The size of this area inside of here determines how much contact the wire will have with this metal, which is screwed into here, which is soldered into here. So if there's not enough contact area for the electricity being called for, now remember, the electricity being called for is determined by the resistance of this. So if the power is getting restricted here because there's not a good connection or there's not enough surface area inside of this connector to flow that much electricity, there will be resistance here. And that resistance will generate heat. Now, that's not really too much of a, you have to have pretty high heat for it to become a problem with the metal inside, but this is all plastic here. And that plastic, as we know, can only take so much heat. So that's when you start seeing the toasty terminal issue, okay? It really is that simple. The greater the surface area you have inside of here, coming in contact with the wire, will reduce the resistance you make at a connection. It is possible to have a connection that has no resistance. It's entirely possible. I don't have any connectors on me, but I mean I've used gigantic lag screws on wire, like 6 gauge, designed for 1/0. 1/0's very tiny, very large. I mean, so you're going to have almost no resistance through there because of the surface area. It's just so great. But that's where we're going to come into the issue. Resistance equals heat. And if you create resistance inside of one of these, you're going to generate heat. And generating heat, resistance is a great way of generating heat. It's a very effective way of generating heat, and we use it everywhere. This is a resistor. The heated bed is a resistor. The inside of there, the hot end heater cartridge is a resistor. It's there to generate the resistance to the flow of electricity for the purposes of generating heat. That's it. Just a resistor. Piece of wire that offers resistance. Nothing more, nothing less. But we don't want heat. Let's go over a couple of components we don't want. We don't want it here because it's going to melt the plastic. We don't want it inside of these MOSFETs because any heat that you're getting inside of there is due to internal resistance, and that's the restriction of flow of electricity. And now there are ways, I'm no expert on MOSFETs, I know a little bit, but there are ways where you can achieve thermal runaway, because if they heat up, they generate more resistance, and it can pile up and become an issue, and you'll achieve thermal runaway, which electronic cigarette users should know what thermal runaway is at this point. If you don't, you're an idiot. Um, Research it. So that's one of the places where we're going to generate heat. We're going to generate heat inside of here. Um, Now, the thing about these terminals, and this absolutely drives me batshit crazy. Look, these are cheap. These are not expensive parts, okay? If I wanted to source better ones, this block right here might cost me $5, and it'll flow some electricity through it, and that's my cost. That's buying one of them with shipping. All right, they're not expensive parts, but yet, I mean, this one here, I don't know. I don't even know the rating on it. It obviously will not say it on it, but I'm going to be generous and say that this guy can handle 10 amps. Yeah, 10 to 12 amps. So now notice I said amps. Okay, that's not volts, and that's not a resistance. Because if we go back to our hose analogy, with the garden hose analogy, we know that amps is the amount of water flowing through it. Okay, it's a separate issue than voltage. Now, there is a reason. Hey Brian, how's it going, man? I'm glad you finally caught in. There is a rating for voltage with these little terminals, um, but that has to do with the potential, and that's the potential to arc across two surfaces. That's a voltage rating. And if you look at the spaces in between here, 12 or 24 volts not going to jump between these two terminals. Now, we're not talking about the PCB. PCBs are different. That's a separate subject. It'll have to do with the spacing and insulation in between all of these little leads and everything like that. But back to this. This could work on 12 volt, 24 volt, maybe even 36 volt. I don't know. I'm not an expert. This one's rated 12 to 24 volt right on there. So the PCB is good for it. So now we're back to amperage. Okay. Amperage is what's going to burn this out because of the flow. So if we're looking at amperage, how do we make it so that this terminal can handle more? Well, we up the voltage. If we use a higher voltage, we can use more resistance inside of here and inside of that heater cartridge to produce the same amount of wattage, but we will be using less amperage. So these terminals here are going to be safer because you're using less amperage through them. Because, as we said, the voltage doesn't really matter because there's giant spaces in between. So now we get into, and yes, okay, I don't know if anybody's watching this later, but people hold the Maker Select into its own category that's supposed to be better than the ANET. They're in the same boat to me. And whatever people think of that is whatever, but they both suffer from the exact same issue. And you know what's the funniest thing is I've been hearing less problems with the new ANET than I have the Maker Select. Maker Select, I hear about problems, we're all on Reddit. Every couple of weeks, max, we'll go before we hear of another one burnt up. The ANET, I haven't heard of one for a little while. I don't know how the new ones are. I haven't tested it or anything like that, so I can't vouch for it. But due to the volume of complaints of them, they're less. They're less than the Maker Select. So that leaves me with either more people buying the Maker Select than the ANET, or they're actually causing less problems nowadays. I don't know. I'm not a doctor. I haven't figured it out. But either way, it's still a problem that affects both machines. All right, and it affects both machines if it's a terminal issue because of these. Now, another thing I saw, and this is the same thing as a ramps board has, um, that these Melzi boards can have plug-in terminals that plug into um, these blocks. These blocks plug into a socket on the board. And what does that do? Okay, now we just created two problems in the system. And by problems, I mean connections. So now we have to worry about, is this going to handle the amperage? And then after that, where it plugs in, is that going to handle the amperage that we're applying? Because you can have great screw terminals, but right after that, if you have just little push pins, you're going to have a problem. So it's better to have one connection than two in a system like that. It just, you're creating more problems than you need to have. Why they put it in there, I'm not sure. Convenience, maybe. I don't know who unplugs and plugs in their heat bed on a regular basis. Um, but it's there, and that's going to create more resistance in the system, especially screw terminals. Okay, you have two flats in here. You have a flat there and a flat up there. And by clamping these two together, you have a pretty decent surface area. Now, push pins have a round surface area. So instead of having, let's say they're the same size, instead of having all this squareness to actually make the connection with, you don't. Now you're rounding it off. So you're having less surface area with a push connection. That's not to say that push connections can't be rated to handle that. Custom-made e-cigarettes, the high-end ones with the XT90 connectors and everything like that, they're flowing literally hundreds of amps for a short period of time through them, and they're not burning up. So they are possible, but there's something going on inside of these Melzi systems where either nobody spent the time to look at what they're making and compare it to what it's being used for, or it's one of those situations where everything is fine on paper, but since we threw it in an enclosure with a power supply inside of it, and the wires all crammed together, more heat is being generated than originally designed for. And that's a possibility too. But either way, from what I've seen, the V1s had the problem. The V2s have the problem. Yeah, I think they have a V2.1 now. I have no idea what that's going to be like, but showing that they've tried to fix this before and failed, I wouldn't have high hopes. So let's look at fixing the issue. All right, and I'm going to focus on Maker Select for this, even though that's not the one that caused the fire. I'm focusing on Maker Select just because I know more about it specifically than the ANET right now, and it's the same issue between the two printers, except one had a fire and the other one's just smoke all the time. So with the Maker Select, you have a version of the Melzi board. It's not an authentic Melzi from what I've read, that there is actually a Melzi board. There's actually a ramps board that's made by Songalulu, I think. Maybe I'm talking out of my ass on that. I don't know. But there is actually a high quality ramps board. But what they're using is somebody got the open source hardware and they cloned it, and they're using a version of one of the hundreds of clones of the Melzi board. To fix the issue, they need to put better, well, they have two ways of fixing it. They can put better connectors on there, which is added cost of what? I priced them out at $250 online. All right, let's call it $6. Let's call it $6 total per board for them to use a better connector on there, which is completely blown out of proportion. But let's call it $6. All right, so now let's tag on $6 extra to the end user. What does that mean for the end user? Is actually they're going to save money.
because in the US it costs about $8 for an external MOSFET, right? So there, by them fixing the problem, you save $2. And if somebody watches this later, please let me know if you violate the warranty on your Maker Select by opening that box or adding the external MOSFET. So I really want to know that, because that would just be hilarious if you had an external MOSFET right off the bat and you voided your warranty because you're fixing a problem that they won't fix. Um, that would just be the ultimate hilarity in irony. But we'll find out later. Um, so the other alternative is, besides replacing these, is to switch to a 24-volt system. Is the Melzi rated for 20 volts? I'm pretty sure it is, and I'm pretty sure it's the same board that they use in their Maker Select Plus or Ultimate or one of those, which is a 24-volt system, which very rarely do 24-volt terminals burn out because we don't have that high of power demands out of our heated beds. I mean, anybody who owns this, Brian, we have 200 watts out of our heat bed. So we could double that. Well, no, not with this board. This board right here, we're probably running, we're 200 watts is about 8 amps. These are probably good till 12. I'll call it 12. Um, but either way, we're running 200 watts, and 200 watts is a lot. The Maker Selects are running like 160, 140. I think the last time I looked it up, the ANET's running 130. So this is already a higher draw, but we have plenty of overhead. In fact, we're drawing less amps on this than the Maker Select still, even though we have a more powerful heated bed. We're still quite a ways off as far as wattage goes from really having a problem like the Maker Select have. So let's talk about 24-volt conversions. What's the total cost? What are you going to need if you wanted to convert a 12-volt printer to 24? You're going to need new power supply. $20. I mean, okay, yeah, we can get into quality of power supplies, but obviously we really don't care about that if we're replacing the power supply that came with our printer, which is already a pretty low quality one. So let's just talk about a direct replacement and an equivalent. $20. I found one for $14 on AliExpress, a 24-volt power supply. The heater cartridge, 63 cents. Fans, 75 cents. Heated bed that's compliant with 24 volts, $7 shipped. I mean, we're not talking a huge price difference here. If I wanted to rebuild this a Maker Select into 24 volts myself, it's actually very little cost. What they mark it up for is a different story, but if the manufacturer did it, they're going to pay next to nothing to do it because they already have worked in the price of a 12-volt power supply, a 12-volt fan, a 12-volt cartridge thermistor, a 12-volt heated bed. So they're looking at adding a couple of dollars total to their cost. Literally a couple of dollars more. Faster heat up at 24 volt too. Yes, very fast heat up. And I laugh at these people that are sitting around for a half hour waiting for that thing to heat up. And I don't know, the mind boggles. 100% with you on that. 24 volts is awesome to go, and I really don't know why we have 12 volts. And 12 volts can fix a lot of the problems. So that's it on these connectors. That's everything in a nutshell. It's not an expensive fix. Companies are cheaping out. And that's why we're having an issue with burnt terminals. And, well, here's the thing, though, is our community doesn't do anything about it either, okay? We know the Maker Selects burn up regularly. We see it over and over again that they're burning up. But what are we doing about it? We're doing nothing about it. If you go on to the recommended printers for for Reddit. What are there in every price category under 600 bucks? Oh, I'm gonna run out of filament soon. Bummer. Um, every price category under 600 bucks, there's a Maker Select in there, and there's the 24 volt one is in there, and the 24 volt one there's no problems with. But here we are. We know this issue happens. We know it happens all the time. We know that it can be a fire hazard, but yet we're still recommending it, and it's hilarious to me. When's the last time you read a car review and they said, yeah, the '73 Ford Pinto is a great car. It's fun to drive, it's reliable, it's well built, but you might as well move the gas tank because it has a risk of exploding in a rear-end collision. That's exactly the same thing. Oh yes, no, Maker Select Mini, Maker Select V2, highly recommended printers. Great product out of the box, except you have to crack open the box and add an external MOSFET when you get it. Am I the only person on this planet who finds that unacceptable out of a consumer good? I mean, oh yeah, no, this computer is an awesome computer. It's great. It's going to do great for you. The price is awesome, but you're going to have to rip out the power supply. Wait, what? No. No, that's not how the rest of the consumer electronic world works. When you have a crappy product on there, you don't buy it, and you tell other people not to buy it. And then when their sales hurt, they're going to build a better product because they want that business. But with 3D printing, they don't need to change shit. They already sell faster than they can make them. But so what motivation do they have to improve it? None. If I sell fidget spinners, hint, if I sell fidget spinners, but the balls come flying out of them, and people keep buying them, am I going to improve it? Hell no. I'm going to keep on manufacturing these things and pump them out as fast as I can and get them into everybody's hands so that they can break. I have no motivation to change something that sells well. So that's the biggest hilarity in it. I just get such a kick out of this nonsense with the, yeah, no, oh, you got to get an ANET, you got to get a Maker Select, they're great printers, but yeah, make sure you do an external MOSFET, have a fire extinguisher around it, a ceramic pad underneath it, fireproof chamber, and you might as well hire a fire marshal to stand by the thing with 2 hoses and an extinguisher every time you print. Are you fucking kidding me? Really? This is how it works. Yes. Unfortunately, this is the sad state of 3D printing, and it's obnoxious to me. It really is obnoxious to me that we're going to go through lengths of recommending a 3D printer that's known to fail, known to cause smoke and fire and all this other happy stuff, but yet, no, great printer, gotta get it. Highly recommended. We write blogs about this thing. I don't know, unacceptable. Unacceptable. Look, we went through the same stuff. Oh, we're going back to 2010, 2011 with electronic cigarettes. This diacetyl incident that you read about, the new hot popcorn lung topic, us vapors brought it up to manufacturers long before the government or media stepped in or even knew about it. And we stopped a lot of companies from using it. In fact, we put a couple of juice companies out of business because the community was so strong and backed by their stuff. They said, change or go out of business. It's that simple. A community uniting can change a market. Absolutely 100% true. That's not the case. It's not. It's not the case. Right now, 3D printing is at how cheap can I get something? We'll worry about reliability and performance and all the other stuff later on. But how cheap can I get this board? How cheap can I get this heated bed? People are still going through ramps. Ramps boards are hilarious to me. I talked to somebody, I've been printing 3 years and I've used a lot of ramps boards. They're great. Well, if they're so great, how are you getting less than 3 years out of them? You're burning through them every 6 months. How great are they? Like, how many have you tried to say that ramps boards are great and know about all these different manufacturers of ramps boards? Well, you know because you burn through them and you fucking throw them away. That's an example of it. That is a direct example of it. All right, I'm done on that rant. That rant. I'm sweating, getting all worked up here. All right, on to the other issue that causes fires. All right. Do I have a pokey dabby? Yeah, I do. Here's a rusty nail for you. Right in there. That guy. Hopefully you saw that. That heater cartridge comes loose over time. All right. You have to go in and tighten that up. Doesn't take a lot of force, but make sure it's good and snug. You can't see it from this angle, but back here is my cartridge thermistor. Same thing. You have to keep that nice and tight. Now, what happens if you don't? What happens if that falls out? Well, if your heater cartridge falls out, you have a good chance of burning your print. It'll fall down on there and absolutely melt and maybe catch fire to it. It's going to be ugly. And I'll tell you why that's going to happen. Is because if you separate the heater cartridge from the thermistor is going to keep calling for heat and more heat and more heat because it's not getting any change in temperature. So that heater is going to get hotter and hotter and hotter and hotter. It's going to have nothing to heat except for itself and whatever it's on. So that can become an issue if that falls out. If the thermistor falls out, you're going to have the same problem. You're going to have that heater keep on heating up and heating up and heating up, and all that heat nowhere to go except for on your fan, the silicone sock, any of this PETG around here, your X carriage is where it's all going to end up. So make sure your screws are tight on there. That is key. Now, there's an issue with some of the cheaper printers, or actually, I really can't say it's with the cheaper printers because it doesn't depend on the printer too much. It actually depends on whoever programs it. There's a way to disable safeties, okay? If I unplug my thermistor right now, just completely unplug it from the board, my printer will shut down. It'll say thermal runaway detected, stop everything, fuck your print, I'm going to bed. And the reason why is because there's actually a minimum temperature set for it to be able to print. And this is done if you have the ramp set up, you go in there and it's at, I think, 5 degrees Celsius. So it's what, like 40 degrees Fahrenheit or something like that? I don't know, I'm a little screwed up on that. 5 degrees Celsius, it has to meet that temperature for it to work. And if it comes unplugged, it's going to read 0. And since 0 is less than 5, it's going to go into protection mode. And you also have an upper limit to that too. Your upper limit will be whatever you set it. If you have a PTFE liner, like Brian here has, somewhere around 245 degrees Celsius is a little hot. I'd probably recommend 240. But that'll be your upper limit. Mine's set to 285 right now because I only have a regular thermistor. I don't have a PT. If I have a PT100, I can go up a lot higher. I literally think 500 degrees Celsius is the limit. I will melt stuff off of my X carriage before I have any concerns. But thermistors are only good to a theoretical 295 degrees Celsius. So if you're hitting those temperatures, that's a little high. That's why I went down to 285. There's nothing that I want to print that's above 285 right now. When I get a PT100, I want to try printing polycarbonate. I'll worry about that when I get there, though. Um, so those are the two issues that we're looking at that cause fires. Now, how can you prevent you can't stop everything. How do you prevent a fire in the first place? Don't leave your printer unattended. Just don't do it. And keep an eye on it. People put them in metal cabinets. That's fine. Just realize that if you have a fire or have a smoke issue or have a problem, because it's enclosed in a metal cabinet, you're not going to see it. So you could make it worse because you're not observing it as much. Um, obviously putting it inside of wood, if we want to go the all-out approach, wood's a bad idea because wood is combustible, and trust me, that hot end gets hot enough to ignite wood. Um, so wood, maybe not the best approach, but clear panels, glass panels, might help. Then you can see the work. You can see to make sure there's not an issue. Make sure your smoke detector is working in your room with a carbon monoxide detector, just to be safe. Um, these are things that are going to help you in the long run. But the biggest thing is just be there. All right. If you're doing an 18-hour print, start it on 6 o'clock in the morning on a Sunday and print until it's done. Don't leave a printer. That's me. That's the hardcore. I'm not taking a chance part of it. I think I've walked away from this printer twice since I got it. One time I went to go cook pizza, and the other time I went to go talk to the landlady. And I was gone for maybe 5 minutes. And even then, I was still nervous. All right, I'm excessive. I know cameras and all this other stuff. I just don't want to leave the thing unattended. Obviously, since I don't leave it unattended, I don't have to do a lot for fire safety and protection. I have a fire extinguisher right outside the door. I could put it right at the edge. Semantics. All right. I'm going to know there's an issue very fast because I'm in the same room as my printer when it prints. But that's the big thing. Those are the big issues.
So that's pretty much it in a nutshell. That's how I feel about it. I'm kind of pissed. And I just wish the community would get together a little bit more and just cut the bull crap. I mean, really. I mean, the funniest part is I was reading this post of them hammering GearBest for saying, like, have a good vape at the end or something like that. And it's like, are you fucking kidding me? At least when they see something that they don't like. Alright, here's a great example. There's a YouTube reviewer called DJLSB Vapes. Okay? What does he do? He takes electronic cigarettes apart. I mean apart. Pulls out the board, pulls out all the connectors, looks at every inch of them. Okay? Tells you what he knows about this part and that part and the other part. Gives his opinion on it. And then what does he do is he screws into the top here, instead of an atomizer, connectors for testing equipment. He measures how fast the delay is before it fires. He measures how much power it draws in standby mode or with the screen on. He measures the actual output and compares it to what the output on the display says. He measures how well it charges the batteries in balance mode. He goes through the electronics piece by piece, every inch of them. We have a guy, he's not on YouTube, Mooch315 on Reddit, and he's Mooch on Vapescape, on Electronic Cigarette Forum. All this guy does, and he gets like $4,000 a month for it, is test batteries. Every bit of every battery ever used in these electronic cigarettes, he takes them and he tests them. If they say they can draw 40 amps, he'll be there to call out the bullcrap. He comes up with actual factual results, and that's why he's making $1,000 a week to test batteries, is because his word is good and we can trust him. He's unbiased, but all he does is scientific testing on batteries. Why don't we have this for boards? Why can't somebody good with electronics hook up test leads and do infrared sensing on these terminals and, you know, measure the pulse width out of these MOSFETs, see if they're living up to what they say they're doing. Nobody does this stuff. Let's see these theoretical print speeds. You know, how many pulses can each one of these stepper drivers put out? Let's see if it actually does it. Let's see if, you know, if I set the in my Duet Wi-Fi or through these leads here, these screws, how you adjust the drivers. If I set it to 0.8 milliamps, why can't somebody hook up a test lead inside of here and see if there's actually 0.8 milliamps being drawn, or 0.8 amps? You know, electronic cigarettes are taken seriously. 3D printing is not right now. Yes, okay, there's exceptions to every rule. Absolutely. There are plenty of idiots that don't belong to use an electronic cigarette, and there are plenty of complete professionals with 3D printers. But it's not like electronic cigarettes have. They actually have a very structured and regulated system, and they do a good job at regulating themselves. Mainly, the biggest issue that comes up, and that's kind of with both, is when you have a safety issue developing an electronic cigarette or a 3D printer, it's mostly the user, except for these damn terminal issues. Seriously. But everybody has to hammer the papers. Yeah, no, what a joke of a bunch that is. Yeah, well, where the fuck is your 3D printing scientific testing done? I'd love to see a video of it. I'd love to see somebody hook up a probe to one of these boards. You don't. You don't, because it doesn't exist. Alright, I'm all worked up. But that's pretty much it in a nutshell. I got something pretty cool. I'll show off real quick. Got some bearings. Yeah. And I got some bearings. Oh, what are those from? I don't know, man. I don't know. Trade secret. If I can get this working right, there might be an Etsy store coming, because although I can sell these guys all day, I kind of want to get something a little more unique going. So, and I can literally sell these guys all day. I can't make them fast enough. So, we'll see. That's my big project for the day. Got a little time left on this print. But after that, I am shutting down, and I'm going to start playing with some fidget spinners. So thank you for watching. Thank you for listening to me rant. It's been real. If you disagree, leave comments in the doobly-doo. Feel free. And if I hear anybody say you don't know what you're talking about as their argument, well, I'll know I've won the argument, and I'll probably just, I don't know, no, I'm going to highlight your comment. I'm going to just hammer the shit out of you. Alright, guys, I'm signing off. Thanks for watching.